Well, hello again from Victor Echo 6 Bravo Golf Tango. I got a small story to tell you here. I usually do a yearly maintenance on the water-cooled amplifier. It needs its water changed because of high voltage leakage, etc. I usually do this in September, so it's all ready to go by the time the ARRL contest comes around in the end of October. But things kept getting in the way, and I got stuck doing it late. The big reason for having to change out the water is because of the high voltage that the amplifier runs on. As the water gets corroded or old, it tends to start leaking current, high voltage current, through the water to ground, which also makes the amp suffer. I have a system that measures this leakage and lets me know when the water is getting pretty bad. So this is how it's done. So first off, I'm going to get the amp fired up. First things first, I got to get the water flowing for the amplifier to even come on. And like I've shown before, this is done through the touchscreens of the Nextion displays, which unfortunately doesn't display very well here, but you get the idea. Here's a better show and tell. Shows me the flow meter pulse rate is up to where it's supposed to be. The one is to 28, and I think the other one's right around 26 or so, which is typical for this amplifier. Now having a good flow rate from the water pumps going through the cavities, the PIC circuits and the power supplies will now allow you to start up the AC side of things on the power supplies. Filament circuits switched on next. Then finally the high voltage circuits will be initialized, which count down for 2 minutes for proper filament warm up in the tubes themselves. So on the back side of the amplifier there's these 2 meters, one for each cavity. These are connected to one of the water manifolds that is insulated from ground. So the high voltage current leaks through the water into the middle of the manifold up through the meter to ground, and this is where we measure it to see how bad it is. So this is a close-up of one of the meters, which is going to demonstrate the leakage. That black smeary pen mark in the middle is where it would normally sit if the water's brand new. So we're just going to wait for the high voltage circuits to kick in, and then we'll see what happens. There's a 2-step process for the high voltage to come on. It's a slow step start, which slowly brings the voltage onto a certain level, I think around 600 volts. And then it turns the high voltage on full bore, and that's when it gets up to around 1600 volts, and you'll see the meter jump. So the leakage is getting pretty high. It's way past the pen mark I have on the scale of the meter. The other cavity's leakage meter shows roughly the same, so they're both well over due for a water change out. The meters on these are roughly 1 milliamp full scale, which is quite a bit at 1600 volts through water. So this is how it's done. Usually once a year I'll just take the tubes out and clean them, but every other year I do a complete cleaning of the whole water system. So looking the system over, the next thing is got to get the water out of the pipes. Got to get the water out of the amplifier so when I disconnect everything it won't be pouring all over the place. So this next little step, don't laugh too hard. You heard of an old blowhard? Well, here's a perfect example of it. I really can't think of any other easy way to do it. I just merely pull the water exhaust line and blow into it until I flush all the water out through the lines, through the cavity, and back into the tank, kind of backwards, going back through the pump. It takes a little bit of pressure, and you can tell by the color of my skin or my face that it's getting there, but it takes a bit of pressure. Take note of the color of the water going through the plastic hoses up to the amplifier, how it's kind of a rusty red looking, like I said, it's kind of scroty. Well, both our lines are blown out, and that's how it's done. Next, to get the chassis all disconnected, to pull it out, is pulling all the RF lines off the semi-flex cable coming off the amplifier that goes up to the combiner. Get them both disconnected and tucked out of the way. Finally, the main water lines themselves are going to go. I don't try and disconnect them. I just simply cut them off with a cable cutter, because I'm going to replace the lines anyways. And they're pretty well dented where they fit onto the fittings, so they can't really be reused. So easier just to cut them off. When I disconnect the lines, I do plug off the ends, because they're going to be laying on the ground, and there's still water in the system, and it can run out and make a mess all over the floor. Well, the water line's taken care of now. I guess all left is all the cabling that's on the back of the chassis itself, which is a job in itself. Finally, we can pull the chassis out of the rack and lift it out. Actually, it wasn't all that bad, so here we go. Oh yeah, I forgot about the rack screws. There's 8 of them to pull out. Just one more thing to do. Now the good old Milwaukee electric screwdriver, I don't know what I'd do without it. Normally, if this was an ordinary, just a tube cleaning, I wouldn't have disconnected any of the lines at the back or the water lines. I would just merely pull out the chassis like this and lift the tubes out right at this point and clean them. But this is a little more involved, so few more steps. Okay, I'm trying to get fancy here. Haven't got 2 cameras again, so not perfectly synchronized. Excuse me. Nice, easy lift. Oh yeah, well sure. Actually, again, it's not really all that bad as I make it sound. So with the whole complete amplifier chassis now on the workbench, I can have a look at a few things. Examination here and a close look there, and oh yeah, we'll see the scrody buildup. For some reason, cavity A is always worse than cavity B. I really can't explain it. I actually had one of these copper lines almost plugged right off. one year when I was checking it like this, and like I say, I don't understand it. Even with distilled water, dissimilar metals, high voltage, they just don't mix. The copper lines on the water jackets of the tubes themselves get pretty corroded up at times, so it needs a good cleaning. I do this like once every 2 years, a major teardown. I guess there's something to say about having a solid-state amplifier that isn't water-cooled. So now the fun starts. I can start ripping the plastic water lines off, and the ugliness really starts to rear its ugly head now. With the plastic lines pulled off the manifold, you can really see the crud that's built up inside the copper pipes themselves. As usual, the one side is always worse than the other, and like I said before, I don't understand that part. Next on the agenda is start pulling the tubes out of the cavity socket holes and get that part ready to clean. Get down in there with my big hand. The tubes are pretty snug into the finger stock. With a little bit of twisting and a slight pull, they pop right out quite easily. Then over to the workbench, I hook one of the spare old plastic lines onto one of the copper tubes and blow the excess water out of them so they'll be more or less empty when I disassemble the water jacket off the tube itself. It's a good idea to have a towel on the workbench because there's going to be water no matter what you do to try and get it all out. Anyways, there's all the 8 tubes and all the old water lines ready to go. Then I go to my trusty Milwaukee and I start pulling all the in and out water manifolds. And they got to be cleaned out also. It's a lot easier having them on the bench than sitting on the chassis, so it's the next step. And of course, more water. I break these apart to clean the insides. The copper plate is just bolted to the aluminum body with a small covering of silicon rubber, so you just got to get the bolts out, put a knife in there and split them open. I thought I was going to see or say that one side is uglier mess than the other side, but in this case they're both pretty ugly. Lots of slime inside there. So I get the cleaning out the manifolds with some memory cloth and end of a screwdriver to flush out the copper pipes, and use some steel wool to kind of clean out the aluminum body part of the manifold, and then polish up the copper pipes on the outside. Just overall, just a good scrub down, and then flush them all real good. So the manifold's all cleaned. I finally get over to cleaning out the tubes. I'm going to show 2 of them here that are really bad and how I disassemble these things. I have a special brass ring I milled out or lathed, and it's split so it fits over the I'll say the outside part of the tube itself, and then I use a hose clamp to clamp it down tight, and that way I can grip the tube snugly for unthreading it from the water jacket. Doing it this way, it doesn't damage the tube. If I use a pair of pliers or something like that, it would probably dent it, and well, it wouldn't be any good for the tube, I'm sure. So I unthreaded the tube parts away from the brass water jacket, and that brown slimy thing in the middle there is actually the rubber gasket that seals it for the water to go inside the tube and not leak out. It's rather slimy looking. Lots of rusty looking slimy muck, and like I said, there's just a couple of these tubes that are really bad like this, so I don't know. I'm waiting to hear what people have got to comment on this one. And as before, how I clean the manifolds, I do the same thing here. I just have some emery cloth, run it inside the copper tube, and clean out as much crud out of there as possible, and then polish it all up with steel wool and color good. Reassembling the tube is just in reverse. Once things are all cleaned up, I just grabbed the brass water jacket, and then with the rubber gasket all cleaned up and softened up with some alcohol, I laid on top. There's a small ridge on the water jacket that holds the rubber gasket in place, and just simply thread the tube back into the threaded hole of the water jacket. Snug her down tight. Almost got ahead of myself here. I was going to say next I put the tube back into the cavity socket, but no. I take some electrical cleaner, good quality electrical cleaner on a Q-tip, and I kind of wipe down or clean all the finger stock metal contacts just for if there's any corrosion on them, just to make it a good solid connection again. So as I reassemble the tubes, I put them back into the cavity one at a time in the same locations as they were taken out. It's a little tricky getting a tube lined up with all 3 rows of finger stock, but you get them lined up and it just snaps back into it nice and tight. So the next one I grabbed, I unthreaded it the same way as I did the first, and it was really ugly inside. Doesn't look too bad at this point. I saw this huge scale build up on top of the gasket and inside the jacket itself. I couldn't believe it. Man, look at that crud. So just like the first one, I got it all cleaned up, all put back together again, and stuck it back inside the cavity where it's supposed to go. This last one I'm going to show you here is the way the rest of them looked. So why those first 2 are ugly, and then the other, 6 other tubes are very similar to this one. Hardly anything in them at all. So again, go figure. Anyways, got all 8 tubes cleaned up and all put back together, and finally got the very last one inserted into the tube socket. Well, sort of. Again, the finger stock was a bit tricky to get lined up with, but it finally made it in there. You don't want to get too rammy with it, or you'll catch some of the finger stock and bend the little ear of the finger stock over, and then you're in a world of hurt because it usually breaks off and it's laying down in a cavity, and that means a major tear down to get that one little part out of there. So you got to take it easy. So next was putting the manifolds back on. This particular manifold is made of a kind of a plastic block, because it's got to be insulated because of the high voltage on the in the water going out of those copper tubes. Little tricky, but it lines up and goes on. It's a good close-up picture here. On each copper tube you can see a tie wrap, and what they're doing is holding these Dallas temperature sensors on each copper tube. This monitors the temperature for each, we'll call each tube, I guess, on the cavity. And it goes up into a common circuit board there, which networks off to the PIC control circuit. It's probably a bit of an overkill, all those temperature sensors, but at the time seemed like a good idea. Kind of neat to look at. So finally, I'm going to start putting some of the clear plastic tubing back onto it. There's about 20 feet of a 1/4 inch of plastic tubing and about 18 feet of the 1/2 inch stuff. And believe it or not, I do have detailed plans on how the tubing goes back onto the amplifier. I remember the first time I tried this, it was a nightmare trying to figure out what goes where, and then this way I can figure out how much I need to go buy the new stuff. So once I got the tubing cut to length, it's easy to install. Just going by my diagram there, it just slides over the copper tubing and goes up to the tube and slides over that part of it. Easy peasy, as they say. At one time, the plastic tubing would just slide over the copper, and it was just a snug enough fit that nothing would leak. But I started using tie wraps, and that was usually plenty enough to pinch it up tight, and there'd be no leaks whatsoever. So remember that statement. This lower manifold, the 4 copper pipes are pretty tight together. The plastic tubing almost touches each other. I can barely get the tie wrap in between. Point number 2, remember that part of the statement also. And the plastic lines going from the tubes to the top manifold is done the same way. Everything's cut to length. It slides over and goes up to the top manifold. And once again, as I've done a dozen other times, I use the tie wraps to pinch the hose down tight on the copper, which should prevent it from leaking. And again, should prevent it from leaking. So finally, after a little bit of mucking around and tedious work, all the tubes were installed, the tie wraps were snugged down tight, and it was looking pretty good. It was time to put this thing back into the rack and see how it goes. Well, I was getting down to the wire here. The contest was actually going to start at moonrise tonight, and this very same day, so I wanted to get this thing back into the rack, hooked up, and get going so I could partake in the contest. Unfortunately, it wasn't going to happen. So I got the amplifier chassis all bundled together, picked it up, and took it over to the rack and put it back down on top of the slides. A little tricky, you got to get things lined up just right, and then push it through the rack, and hopefully everything fits in. The plastic lines kind of hang out the sides, so you got to kind of push them a little bit to make everything fit, but it goes in. Nice, easy way of doing it, I got to say. And it slowly goes in. The amplifier's back home again, back into the rack where it should be. But wait, there's more. I still haven't changed the water in the reservoir tanks. Never seems to end. When you have an amplifier that's water cooled, you better have lots of towels handy because it's going to leak. And sure enough, some of the tubes fell on the floor and siphoned out some water onto the floor of the basement. So, oh well, mopping it up. So that mopped up, I was able to finally get the water out of the tanks and get them cleaned up a little. The 2 tanks fit in this 19-inch chassis. Kind of tight, but you can slide one over to get to the other one. And essentially, you got to pull the pumps out, and there's a temperature sensor and the drain back into hose, and get the lid lifted off, and then I can pull the tank out from the side. This was the clean tank. The other one is the murky one. I don't know what's going on with that part. This is what the other tank looks like before I drained the water out. It's rusty muck slime on the bottom, and when I drain it, wipe it out with a tissue, you can really see it. The other tank is clean compared to this one. So with the tank's cleaned out and put back into the little chassis, it was time to put the fresh water into it finally. I have 5 jugs of distilled water here, and actually I needed a couple of more. So I started filling up the tanks. So I got them all filled up, and there's 10 liters of fresh, clear, distilled water in each tank. After all that, I installed the brand new 1/2-inch feed lines that go from the water tanks up to the amplifiers themselves. I didn't connect the 13 centimeter amp I'm going to leave that till later because I'm going to tear it apart and clean it also, but that's another project. So before I hook anything else up, like the cabling and the wires, I was going to get the pumps turned on and see what's going to leak. It's always been good before. So I started the pumps on the touchscreens here and checked to see if I was getting flow right through the flow meters. Look good so far. Like I said, the pumps came on, and after the air worked its way out of some of the lines, I started checking for puddles. My handy little flashlight, I'm looking around the cavities and looking for drips and stuff there, but nothing found so far. It all looked good. So, as usual, I thought, oh, we're off to the races. As I said before, it's never been a problem, so it's sometimes there's a little drip here and there, but no, nothing yet so far. Sometimes you've got to pull the tubing up high to get the air work its way out better. The bubbles just get caught in there and they can't work their way out, so you lift up the lines and they all work their way out and lines fill up full of water, and it flows really good then. So it looked good so far, so I decided to look down on the floor and around the tanks, and oh yeah, here's a puddle. This is typical. I quite often see a leak here. There's a joint in the tubing here. Sometimes I have to take it apart. The lines will get airlocked when I have a fresh refill, and sometimes I've got to break the line there to get it unlocked and flowing again, but it just leaks, so I usually just wrap it in tape. I continued lifting the lines to get the air bubbles worked out of the lines, and kept checking. At this point, when I got the water flowing quite well, when I got all the air worked out of it, I took my flashlight and looked up inside the amplifier again, and to my surprise, I found puddles all over the place. There was water forming on top of the cavities. It was dripping from the top manifolds down onto the cavities. The tubes themselves were leaking. I was surprised. The lower manifolds were dripping. There was water everywhere. I couldn't believe it. I've never seen a leak like this before. It was a regular flood. I tried doubling up on the tie wraps to make it stop leaking, but there's just no way. It wouldn't quit dripping. So I knew I was beat, and I shut it all off, and a new plan of attack. This is something I've always wanted to build for this amplifier, even from day one. I was just never happy with using tie wraps. They seemed to work, but there had to be a better way, so back out to the garage. Like I said, I've had this idea for quite a while. I have some aluminum metal here. It's a 1/2 inch by 1/4 inch thick, and the idea was to cut them up into 1/2 inch lengths, drill a small hole through them that will fit just snugly over the plastic tubing, the 1/4 inch tubing, and then slot it and turn it into a clamp with its own little screw for tightening. A little tedious to build, but it worked out okay. I thought my arm was going to fall off from all the tapping for the small 440 holes, but finally I got them all done. So I had to pull the chassis out of the rack again and put it on the workbench to install all these clamps. They fit over the tubing just nicely, and when I tightened down the 440s, it clamped them really solid. So I think it was going to be a winner. But that was the easy part. If you remember a couple of frames back, I mentioned that one manifold where the copper tubes were pretty tight together, the clamps weren't going to fit. So it meant building a whole new manifold for these two parts of the amplifier. So I was back on the mill to machine out a new cavity for the new manifold, tap out a hole for the new pipe fitting to go into, and build up some copper plates with some copper tubings that were spaced out far enough for the clamps to fit. So those are what the new ones look like, all machined out and finished up. One for both sides, for cavity A and cavity B. And they mounted into the chassis on those little ledges there with those tapped holes, and clamps fit like a glove. The two manifolds that took most of the time to build, the clamps were nothing. So they were all done finally, and it was time to put things back together again, and hopefully it would work. Well, since I was in the mood for getting things done or built, that I've wanted to do for a long time. This is one more item. In order to keep the larger water lines from being kinked or pinched, it's just from bending, going around corners and pinching off the flow, I was using tie wraps to hold them up, kind of suspended from the larger coax cables. It sort of worked. So I came up with these special brackets that I made out of a half-inch electrical conduit, cut it in half and slotted them so they'd be flexible. These things were rather tedious to build. I would weld them or tack weld them together in the shop, then come back into the shack, see if they'd fit, try and bend them, they'd snap off, so I'd go back up to the garage again and weld it again, and back and forth, back and forth. It turned out to be an all-day event, but it turned out good. Once again, slide her back into the rack and get things hooked up and check for leaks. Hopefully it'll be the last time. So I got all the main water lines hooked back up and the pumps powered up, and it was really quite amazing. There was hardly any air bubbles this time. Just a bit. I had to work out, but it flowed nice. Probably due to the lack of air sneaking into the lines, I'm not sure. But anyways, checking for leaks one more time. No puddles forming on the floor this time. Mind you, I had it taped up from the first go-around, so it should be okay. Well, I'm happy to see that there's no dripping or no puddle forming anywhere on the cavities or on the main body of the chassis itself, so the clamps worked as I figured it would. I mean, it's better than tie wraps, for sure. The only thing I could think of is that the new plastic tubing, the tolerances were just a bit wider or a little looser because they slid over the copper a lot loose or a lot less fitting than it did before. So, oh well, got her licked now. This is something I should have done a long time ago, I guess. So, the water's working, no leaks, so it's time to put the cables on her and hopefully fire this thing up here down the road and get her back in a running order, hopefully with no problems. So the moment of truth. Get this thing fired up and get it percolating one more time. So I go through the sequences of turning various circuits on to get this baby running. So this is a moment of truth with the nice, clean, brand new water, how much high voltage leakage we're going to have. Much better. Before, if the old water is almost full scale, 1 milliamp. So over to the instrumentation panel, we're going to check the idling currents, make sure all the tubes are idling within reason. Some are a little tad low, but most of them are pretty darn good, so it's good for the test. So there's more adjustments to do on the amplifier to get it really percolating well, but next I'll have to do is change water in the driver amplifier here, the single tube, which flows up to a small tank on top of the other rack, but that's for another project, so that's it for now. So if you made it this far, thanks for watching, and 73's from Skip, Victor Echo 6, Bravo Golf Tango.